Got it. All right, I think we are almost live. We're almost live. I think I've set thing right. This is probably going to make it go live. Oh, I didn't set this properly. There we go. Awesome. All right, it's probably live. Yeah, we're definitely live. Here is the Discord invite. I'm going to go give them a heads up that we're going to kick things off here soon. All right, I've given them a heads up. I think that's everything that I needed. Okay, I'll see you guys at 10:45 as usual. Yeah, this is a problem that there was some discussion on the Discord group a week or two back on this problem. So I was like, I should probably cover this. I'm pretty sure it was asked at Roblox. They weren't. it was almost definitely asked at Roblox, so it's probably a pretty good problem. And yeah, we'll kick things off at 10:45 as usual. Okay, it is 10:45. We are probably good to go ahead and start kicking things off. All right, so this is the scheduled digital transaction problem. This is well, so all I kind of got was a prompt. It was kind of on me to pick a name for this. Let me close this really quick. So all I got was a prompt for this. We didn't actually have a name. I think this is probably the best name I can come up with for it. It's some kind of digital transaction, and we just kind of want it to happen at a specific time. So it's kind of like a combination of the digital wallet problem combined with the distributed cron problem. Like I said earlier, around like 15 minutes ago, I'm pretty sure that this was an interview question that somebody received at Roblox. The original prompt, so I'm stealing these from the information that was given on Discord for the problem. The original prompt only specified 100 TPS for the transactions. So that's rather low. That's rather low. I think that doesn't really make it as interesting. So if we have time, we're going to maybe make it a lot more interesting by cranking up the TPS on those transactions. Because 100 TPS like that can fit on one machine. 20 terabytes maybe be more of a stretch. You can maybe work around it by doing some kind of archiving trick or something. But it still is like I don't know, at 100 TPS that's kind of boring in my opinion. So we're going to look into some ways to make it a little more interesting. So one of them is, hey, let's crank up the TPS. There's this assumption that we have unlimited Robux. So that was one of the issues that one of the partial failure scenarios I think would be really interesting in this problem is if you had if you were treating it as an inter-count transaction, as in it's between two friends, you just schedule like, for example, sending $10 to a friend over Venmo tomorrow at 9 p.m. or something like that. That would be pretty interesting because like, what if your account balance got drained by then? What if you spent all that money by the time that the actual transaction was supposed to occur? This is not actually supposed to be with real money. It's with Robux. So that way you don't have to worry about all the like PCI stuff that would make this really hard and really not fun in the real world. We're going to go ahead and keep assuming that we're working with Robux instead of real bucks, just to kind of simplify things a little bit. I don't even know what all would be entailed with working with real money in order to meet that PCI compliance stuff. And I've actually worked at a bank before. So one thing, crank up the TPS. Other thing, I'm gonna maybe try and show how to handle that partial failure scenario so that we can clean up the problem a little bit more in that scenario. I don't see any questions yet in the live chat, so I guess we can go ahead and start kicking things off. If you guys have any questions, feel free to let me know. Feel free to post something in the comment section in the live chat. Otherwise, yeah, we're going to go ahead and get started. All right. Okay, so you're going to need, I'm going to say browser. It's a browser or upstream system. Because when they said it was unlimited, and it's to a specific account ID, there's not a sender account ID. So it's phrased in a way where it's more like all of the users just get a certain amount of Robux just deposited every single day at a specified time. It's just free money from the powers that be or something rather than a between friends transaction. So there's no sender ID, it just has a receiver ID. So that would make it an upstream service rather than like a browser, a browser or an app. There's just some kind of upstream service that for whatever reason, it's going to send something downstream and it wants to schedule this transaction. So in our variation, we're going to switch over to browser, but for now it's going to be upstream service is really the key way of describing this. We're going to need a backend service for receiving that request for a transaction. And then we're going to go ahead and pop that into a database. That is, of course, not going to be enough to get it scheduled. I mean, you could do polling. Actually, that is an approach that I didn't even capture that in my notes, but like that's another thing that I guess you could even do is polling instead of cron. I don't think I even covered that in my earlier distributed cron, cron coverage. So there's distributed cron as one approach, and the other one is that you can do polling. Let's go ahead and record that as approaches. There. I, of course, always share the file at the end. That's why I'm taking the time to type that out. So we have the backend service, the scheduler service, and then we got the, what are we going to call this? The event timestamp DB. Okay. So we got our request is going to come in, and then we're going to go ahead, we're going to write it to our database. Let's curve that arrow. And then we're going to say, yep, we've recorded it. Thumbs up. Okay. And then we're going to use the write ahead log. We're going to use a DB trigger. So the DB trigger goes off of the database's write ahead log. I'm going to come back and cover the schema here in a minute. But so we're going to have a DB trigger. It's going to go off to some task runners going to handle replicating it to. So I'm first going to handle the distributed cron approach. There's actually kind of like a couple of ways to even spell that out completely. We've got a DB trigger is what we're going to use. This should be large. There we go. Got some task runners, and they are going to replicate that out to, we're just going to have some like cron replicas. So not task runners, it's just some cron replicas. You can shard it. So in case there's like a lot of events, I guess we wouldn't really necessarily need to shard. In this case, this would probably be more for in the higher volume approach. You probably don't even need, you probably even just use one machine that's replicated into a whole bunch of just exact replicas of one cron tab file rather than having to shard it for 100 TPS. But if you're going to do higher scale, you would maybe need to do the sharding along with the replicas instead of just the replicas. But you will be making these cron tab replicas over here. And then this is going to handle the scheduled aspect. There's actually two approaches for cron. You can use cron itself. You can use actual cron, or you can use Golang threads. So when I was doing my previous coverage of distributed cron, somebody had actually said that they've actually used Golang threads in order to implement cron themselves, kind of. And I thought that was wild. I've always thought that like if you're going to do something scheduled, you're going to need to use cron for it. So like if you're scheduling something for hours into the future or for days in the future, I always thought cron was the way to go. Apparently somebody has used Golang threads, and actually if you think about how you're going to manage the cron tab file and how you're going to remake it, it's I guess Golang threads does actually maybe kind of make sense. And Golang actually is very there's very little memory required for spinning up a thread in Golang. So I can totally see that. I can totally see Golang threads as another way to accomplish the distributed cron approach. And then of course you got polling. I see a question in the chat. I'll get to that, and then we can go ahead and try and start filling out more of how the scheduled part is going to work. What's a DB trigger and how does it work? Okay, that's kind of like a really basics thing. So when you write a record to a database, you can set up this thing called a DB trigger, where every time you write or update a record in the database, it'll automatically kind of like react to that. The way that it works is I've heard it usually runs off of a database's write ahead log. So there's the write ahead log. Beyond that, I really recommend that you do some of your own research. And so I've got some resources on, let me pull this up really quick. So I've actually got a GitHub repo that has a whole bunch of resources on it for some stuff that you can read. For how to set up a DB trigger, you might want, I don't know if this guy's actually going to talk about the inner workings of a DB trigger, but I feel like he probably talks about write ahead logs a little bit. That one, actually, that's probably a little bit too heavy. That might not actually be the best approach. You might actually just kind of want to try Googling that one. Yeah, I don't know if any of these actually talk about how DB triggers work or what they are. You might want to try Googling that one. But here, I'll go ahead and post this into the chat. It might still be useful. Not all of my viewers have seen that before. For those that have been with us for at least a few months, you've probably seen that before. But there's some people that are just kind of picking up on this channel just recently. So that's why I had to share that. Yeah, I'd recommend Googling that. I'd recommend Googling what a database trigger is. It's really commonly used for change data capture. It's really useful for sagas, for example. Sagas are another thing that really rely heavily on DB triggers in the way that most people do them. That was probably not the best explanation ever. I think Google's maybe going to be your best resource there. Let's go ahead and move on. Yeah, if anyone else has any other questions, feel free to share them. Yeah, I like to try my best with any of the questions you guys ask, though. Yeah, all right, let's go ahead and move on. All right, so we've got the cron replicas here. We got the cron replicas, and those will be, you can either use Golang threads or you can use actual cron tab. Either way, at some point in time, they're going to activate, they're going to hit their actual timestamp. So Golang threads would work similarly. So they're going to activate, and then they're going to send off a request, and we're going to have, so there's two different approaches that I had come up with on handling this for the distributed cron coverage that I had done before. One of them is a dedupe service. And then you're going to need to have some kind of database that has a stronger consistency guarantee or a stronger isolation guarantee. So it's going to work together with a database, a data store that would be able to provide a proper, unique key to check against on a specific machine. What did I call it? Just dedupe DB. So you're gonna have replicas, like I said. So there's actually going to be multiple requests that get sent off at roughly the same time, and you're not going to want to have multiple transactions occur. Actually, you don't. I don't know if you actually need this here. I don't know if you actually need to dedupe it in this case. This was useful for notifications for distributed cron. You don't actually need the dedupe service here. You can just go ahead and have the multiple things, and then we're just going to make the request idempotent for the actual transaction. So I guess we don't even really need the dedupe DB in this scenario. I only had that for cron for trying to minimize the amount of, so if you're trying to do at most once instead of at least once, you would want to do that deduplication, but you still want to have the replicas because that reduces the risk that you would actually get 0 requests. You still want all the replicas to minimize the risk of having 0 requests in the at most once delivery scenario, but we have at least once delivery because we're going to do idempotence. With that, we should probably discuss the schema and how we're going to make this idempotent. So the key here is going to be that we will want to have an event UUID, or I guess we could even dedupe off of the account ID, but we would still need to maybe have the timestamp involved in that, which is why I'm suggesting that we might want to have some kind of UUID involved. So we're going to have, you're going to need the account ID of the person that's going to be receiving the funds. You're also going to need to have the amount that you're sending. You're going to need to have the amount of Robux that you're sending. You're going to want to have the timestamp that is scheduled for. So scheduled timestamp, you're going to need that. That's going to be a Unix epoch time, so it'll look a little bit like this. And then we'll say we're sending, I'm not familiar with Robux and what a lot or a little is, so I'm just going to say 500 Robux. I have no idea if that's a ton or stupendously small amount. And then for the account ID, I'm going to assume that the accounts are, actually, let's just use like usernames, and then I'm just going to use my one from Discord for that. There we go. And like I said, we're probably going to want to deduplicate it. And so if you're going to schedule multiple events for the same account, then that means that we can't dedupe off of account ID alone. So like I said, you're either going to need to combine the timestamp somehow in order to make it, in order to make each scheduled event separate, or you would use, like I said, a event UUID. So something like that. And you're just going to use this as a key for deduplicating the requests. Somewhere down the road, you don't need to actually dedupe right here. That was for when we were trying to do something more like notifications. This would just be I guess it could be like the send service. I don't know if you actually need another thing between this and the transaction service. So we're going to have a transaction service downstream. Or a wallet service. It's either a wallet service or a transaction service. I'm kind of looking through some of my other notes for digital wallet to make sure I'm not doing something completely ridiculous. Okay, yeah, transaction service. Okay, and we're also going to have, well, okay, we're going to say this is the wallet service. And each wallet is going to have a bunch of transactions on it. So you're also going to have the wallet data store. Okay. And do I really need this service here though? Do I really need something? Well, I don't. So I've never had anything like this in prod, and I feel like you wouldn't want to have it. You don't want this to be so wallet service is not calling this. It would maybe just be, so you'd have the event UUID, and then this thing could maybe map the, it's like, what actually does the API call? Do you actually have the thing hosting the cron replicas doing an API call, or does it just activate, does it just call its service? Is this going to be like a reusable cron component? I guess this should just be like the send service. It's a totally optional component, just maybe for decoupling parts of your architecture a little bit. And so like you would maybe say that like this chunk is like something that's owned by, well, no, it wouldn't be like that. It would be like this chunk is owned by a team. But I don't know if you really need that for decoupling it. So you got a couple of options here. I don't know whether or not you would actually need this. Okay, so you'd have that, and then you would have, so it's time to do the actual transaction. So you still haven't completely deduplicated it. So we're going to do the actual deduplication is going to be on the wallet service. So you're going to have still 3 are going to come in to the wallet service. And so whenever you're working with money, you need to deduplicate things anyways. And so that's why, you know, there's not really a point in deduplicating it upstream, because otherwise you're just going to it's like this thing needs to be designed for deduplication anyways. So you don't need to do it upstream because this should be what's deduplicating stuff anyways. Okay. And so for the wallet data store, for low TPS, you only need one machine. You only need one machine, and you can just use regular PostgreSQL. And so you're just going to have like the accounts, and you're also going to have the transactions table. So you're going to have a transactions table, and that's where you're going to do the actual deduplication. I'll explain how that works in a minute, but that's where you're going to see the UUID. And so then when the second transaction, so when the first transaction comes in, you'd write this new transactions table that has that UUID in it. And then when the second one comes in, you would see that the transaction UUID is already there. So you're not going to write the new transaction. It's already there. You just say, I don't know if it's a 50x, a 40x, or you can just say a 200. I guess you can just say 200 transaction already received. So it would deduplicate properly. So you have the transaction UUID in the transaction table. You have wallet table. Have the account ID, and you're going to have the balance. I'm just going to say that I have 200 Robux to start with, and then you write this transaction, and at the same time you add the 500 to the balance, so it gets updated to 700 in the same PostgreSQL transaction as this record is getting added. I don't know if you actually need to have any other information in this. I mean, I guess you could record the amount. I guess that would maybe be useful for debugging it later. Okay. For debugging purposes, I guess it would maybe be useful to still have the timestamp and amount for the transaction. That way, if there's anything that goes wrong, you can like replay the transactions to make sure the balance actually adds up properly. Okay, so this would work. I see a couple of comments in the chat. I'll get to those in a minute. I wanted to kind of summarize where we're at so far, just kind of make sure that I've kind of explained myself a little bit, and then we're going to go through the chat. Okay, so the request comes in, you write it to the event DB, you say 200, okay, we've recorded it. And then you use a DB trigger to actually get it scheduled. So it's scheduled on the cron replicas, and then at the provided timestamp, this thing's going to activate. It's going to send a request. There's replicas, so there's multiple requests for the same exact transaction that are going to get spun out. It's going to hit this. I can totally remove this. It's, yeah, I don't know. I feel like it might be necessary for properly decoupling. And then we haven't deduped yet, so all replicas are still going to go over to the wallet service. And then the wallet service is where the actual deduplication is going to happen. We're going to use that event UUID as the transaction UUID. And then only one would actually get written and actually change the balance. So if it starts at 200, it's only going to go up to 700, even though 3 different requests come in. And then that's going to say 200 OK for all of them. 200 OK. And yeah, it's yeah. Okay, let's look at the chat. And then I can try and work through more variations. I think the first thing I'm going to do is redraw this diagram without the send service there. That's just bugging me so much. Let's look at the chat first, though. Okay. Can you please explain in some more details? What is the job of cron replicas? So it's for redundancy. It's purely so that if one of them crashes, you won't lose that scheduled job. It's like if it's just for redundancy to make sure that you don't lose an event if it breaks. I guess you can, so like if you don't do the redundancy, I guess you can rebuild whatever was supposed to be on there just fine by just, you just have some kind of auto scaler or whatever it is that like watches, maybe it's like Kubernetes, it'll just detect that something's down. And then it would, do a key range query to look for what is supposed to be on that cron replica that went down. And then it would, rebuild the cron tab file, write it back to that machine. That might take a little bit of time though for doing that key range query. Generally, you don't want to have to rebuild anything that you need redundancy if you're going to have to rebuild something that's large. So, for example, sometimes I've seen people in their system design diagrams, they would point out a box. They're going to say, this should have a heap. And it's like, okay, well, so heap data structure. Yes, I'm familiar with that. If you say just heap, it's like, okay, well, that would be in memory. And then if the computer, cycles, if it turns off and on, just general data center badness happens to it. It's like, okay, well, now you need to rebuild the heap. If you were getting that heap off of a gigantic Spark job, or, it takes hours to rebuild that heap after, building up the data in it for 24 hours on end or whatever, you're not going to have that up and running again for another hour. And if you're handling OLTP queries off of it, that is 1 hour of downtime. And so you've just kind of killed your 6 nines or 7 nines of availability budget for like the whole month or something. So it's if the cron tab file can be rebuilt in like a minute or less, I don't think you even want to spend a whole minute rebuilding it. You really want to have that thing like right back up and running if you have a high availability service. So you would prefer to have replicas that would still be able to service queries and would still be able to activate and send those events even while the first one is down. So that's why the replicas and redundancy is necessary. It's that you want to still be able to service queries while rebuilding one of the replicas. Good question. Good question. So for redundancy, if any of the nodes dies. Okay, is this designed for a single system to assign resources for each job, or is it designed for a distributed system? So the whole thing from end to end, this is for like system design interviews, for example. It's for a service, like a backend service. It's for the backend of, for example, Roblox. It should be designed for handling 100 transactions per second. That does fit on a single machine. It does, and so with the first one, I did say at the start that like I don't think we even necessarily need to do sharding over the cron replicas. You would maybe just do some redundancy there. That would probably be fair. You might even be able to put this database and the other database on the same machine, although you would probably want to decouple them in a large company just to not have any issues with having like too many cooks in the kitchen. Like I'd imagine a different team would be working on the wallet service than what the one working on scheduling transactions possibly, or whatever's kicking off these transactions. Yeah, these two things seem different enough that you would maybe want to have those two different databases owned by different teams, and they should be loosely coupled. It's bad practice to have two different teams working on the same database. So this one and this one I'd see as realistic for being owned by different teams. And so then they should be on different machines. I guess you would only need like a couple of machines running cron possibly for redundancy. For the wallet service, you could maybe, well, like I said, 100 TPS and maybe just one machine there and one machine for the data store itself. And then the SYN service, I said, could be completely eliminated. I'm actually starting to regret drawing that at all. One machine here, or well, so you'd actually, so I did say one data store for this, but I think you should still have at least one synchronous replica. Anything that you're gonna have up at the scale of Roblox, if you actually experienced any kind of data loss, that would still be quite an embarrassment for the company. So you do still probably want to have at least one synchronous replica there. The rule of thumb at Amazon is actually n+1 machines, as in n is enough to handle the scale, and then +1, so that if any one machine goes down, you have one extra one that would handle that scale. So maybe two machines here, like 2 to 3 for all the cron replicas, because you're not going to do sharding. 2 machines here, 2 machines here. I think that would probably be fair. But yeah, it's for a high scale service or high level design. How cron replicas organize the tasks and allocate resources. I'm not going to go into the details of how cron works. One of the other alternatives for this is Golang threads is another approach, is where you just I haven't even done this myself with Golang. I thought that was actually kind of weird when I first heard it, that you could just replace cron with Golang threads. But that is another way that you could kind of go about it, and they're just going to be sleeping for like 99% of the time. Were you thinking about some kind of distributed queue instead of SYN service? Yes, I was. So if I was going to do, I had dedupe service there up on there for like a few minutes, maybe like a minute. Let me go ahead and start sketching this out a little bit. So my original coverage of distributed cron, instead of one of the alternatives to dedupe service, I actually had Kafka in there. And I was wondering if I could just go ahead and have Kafka do the deduplication for me. I thought maybe that's realistic. I don't know if Kafka actually has that kind of capability. But I was like, I don't know, that's one proposal. Maybe there's something in Kafka for handling deduplication of the messages. So if you sent a message multiple times to Kafka and it's just supposed to be the same one, under a certain partial failure scenario, does it just go ahead and dedupe your message somehow? But yeah, that is one of the approaches that I was considering. I guess I can just go ahead and leave this here. that makes the diagram look a little ugly. We're gonna move things really quick here. There we go. Okay. Maybe the send service hosts that queue. So a service generally should be different machines than what you're using for hosting your message broker. Message brokers are generally on different machines than your services that you have. Maybe I'm overanalyzing this, and you mean just like, hey, maybe by send service you actually mean Kafka as a stream, just Kafka stream, like that can be your send service. In which case it's like, yeah, I can see that. Yeah, I don't know. I think it would probably actually even like if I was drawing this at Amazon, like Kafka, putting it in there, like regardless, like I would totally see that there. I could totally see some kind of stream in there for if I was making this at Amazon. At other places though, they're not as used to having like, I don't know, like hundreds of microservices. And whenever you add a box to the diagram, they go, whoa, extra complexity. Let's tone it down a little with all the microservices. So I was at Amazon for 3 years. I'm at a different company now, and they're giving me that kind of vibes. It's like every time that I propose the idea of adding an extra box into our architecture, it's like, whoa, extra complexity. This is nuts. Why do we need so many services? And so now I've got that in my head, and it's like, extra box there. I don't know. But yeah, at Amazon, Kafka there, totally, absolutely. Okay. Not in place of send service. I was thinking in place of cron replicas, we could use some distributed queues. Well, so like if you put if you want it to happen at a specific time, queues don't do queue. Maybe some message brokers have built-in capabilities for doing things at scheduled times, but that's generally beyond the scope of what you would have as a feature of a message broker. Message brokers generally do not delay the send of a message for a period of time. They just kind of hold it. Message brokers are a lot like just a pure write-ahead log. I think Martin Klapman even kind of goes over ideas like that a little bit in some of his writings that he has out there. But they're a lot more like just a pure write-ahead log, and you're not supposed to try to stick like a delay on them. So that's why I think that having the cron replicas or going threads here is maybe a good idea. I really want to draw out that alternative of using polling as another approach. I think Dropbox had a design for job schedule that used polling. And if you go for really high volume, polling is really going to make even more sense. I'm actually going to draw that next. I'm going to do 1 or 2 more messages, and then we're going to go ahead and draw the polling approach here. Yeah, so 1 or 2 more messages, and then we're going to do the polling approach. So as per the timestamp in which the jobs are submitted, DB triggers activate the cron replicas, which in turn will execute the jobs via wallet service. The DB triggers write to the cron replica. So you have files hosted on these cron replicas. It's a cron tab file. So cron is a Linux utility. Cron is a thing that's like built into most Linux services. It's a thing that allows you to have an individual machine do a thing at a specified time. So the task runner is just writing updates to the cron tab files, basically. And then the cron tab files are going to activate on their own at a certain time because they have that written to their cron tab file. And so then there's a daemon process running on those machines that checks the cron tab file and then activates at specified times on the cron tab file. And then when they're activated, it'll do a specific thing. In this specific case, it's going to make a call off to the send service, or it's going to write something to Kafka, or it's going to call the wallet service just directly and just circumvent these extra boxes here. Okay, this will be the last question before we try polling. I noticed you use database trigger for change data capture a lot. Yes, I do. Yes, I do. I'm just going to comment there. This requires polling. It does not. It actually does not require polling. It's so DB triggers are like built into databases. It's like you're able to write a little code that activates whenever you do a thing. If you've ever used PostgreSQL or DynamoDB, you can actually set up database triggers on those. I think even I think Redis also has some built-in capability for database triggers. It's a very common feature. Most databases support triggers. So like I said, even PostgreSQL has it. If you've ever worked on a Linux machine, if you've ever done a hackathon project, you had to set up a database for it, you've worked with a thing that probably supports a database trigger. And so you can even just check, just do a little Googling on database triggers, and you just are able to execute this little bit of code whenever a record is written, created, or updated when you modify an existing record. So it's not polling, it's just a thing that, and that usually goes off of the write-ahead log of the database is how it's implemented within the database internals. So you don't actually have to know that works off the write-ahead log. That's just a fun fact. But that's like built into the database itself, is that it's, you write the record, and then the database knows to go ahead and push out this change to, it's a lot of the times DB triggers actually will be used for updating other records of that same database. So it's like you write the record to the DB, and then asynchronously it's going to change other records just on its own without having to interact with any other machines. So no polling involved, to my understanding. DIA talks about write-ahead logs. Yes. And sharing my thoughts. So I used to be a lot more afraid of DB triggers. I used to not think they were a great idea. I thought they had a lot of overhead. They're actually pretty great. They're very useful. Write-ahead logs, originally write-ahead log just seemed like it was a safety mechanism, but if you read some of the stuff written by Martin Kleppman or some of the other people that are just really good at the theory stuff and internals of databases, write-ahead logs are actually, it's just interesting how they can integrate with other stuff like DB triggers, I think, go off of write-ahead logs. And also with replication, when you're replicating nodes of a database, one of the ways that you can go about replication is actually just copying the items in the write-ahead log downstream to the other replicas. So it's yeah, I don't know, they're actually a little bit more fascinating than you might have the first impression of. I really want to make sure that I'm making some progress on the problem itself. Great questions though. Let's go ahead and take a look at how this would look with polling. So this was cron or cron/going threads approach to scheduling. And now we're going to do the polling approach to scheduling. Okay, so we got, let's delete this box right here. I regret having that send service right there. And then we don't need to have the cron replicas anymore. Instead, we're just going to have some stuff that's just polling. So instead of having the DB push out some stuff that is also going to push out, we're actually going to be doing polling, just a little bit more of like a push, we're actually still going to have task runners there. We're still going to have task runners, but they're going to be kind of flipped. And I'll show you what I mean by that here. So we got the DB there, end of story, and then we got our task runners. They are the polling task runners. They are the polling task runners. So we're going to have them set up to every minute, every 5 minutes possibly, or just maybe even just once an hour, just whatever frequency that you want for the recency. They're going to do a read against that event timestamp DB, and they're going to be doing a key range query for things that are past the specified timestamp. It's going to be checking for things that have now met their timestamp criteria, and we can do. So if we're doing this once a minute, we would check for things that are within, what is this, milliseconds, or is it seconds? I think Unix epoch time is in seconds, and so then every 60 seconds you would do things for you would check for events that are in the range between this timestamp and then also this timestamp plus 59 seconds. So it would be select star from event table where scheduled timestamp is greater than this, and scheduled timestamp is less than, say, like 59, greater than or equal to that, less than that. So it would look more like that. And then it's going to do the poll, and then you're going to send off you're going to go ahead and call the wallet service for that. And then you don't even, so it's not going to have multiple of each of those things. It'll just be one, but the wallet service should still be able to deduplicate in order to handle partial failure scenarios properly. Otherwise, what you would have is that, so you're sending this request off to the wallet service, and then you could have a partial failure scenario where the response packet gets dropped, and then this thing would get a 404 or something, and it would retry the request. And if you weren't deduplicating it anyways on the wallet service, then you would end up with 2 transactions for that 500, and then I'd end up with a balance of 1200 where it should be 700. So you still need to do the deduplication on the wallet service, like I said. But in this case, it's the happy path will only end up with 1 transaction occurring instead of like 3 or 4 or 2. Like the default happy path just results in 1. Okay, so we're going to go ahead and label that polling. I'm going to check the messages here in a minute. I'm going to move this down so it's a little bit more clear what I'm saying. And we're going to do that. Move this down here. There we go. Okay. Where is the initial Robux timestamp account ID stored? Right. Okay. So they are just kind of coming in from upstream. They're just kind of coming in from upstream. So like, there might be further other services upstream, like an account service or something. We can safely neglect those because they're out of scope for the problem, but we will be receiving a request that will specify the account ID, the amount, and the timestamp of what we want to have occur. Those are going to be coming in. We don't know where they're stored. We don't know who's sending them. Those are irrelevant for the problem. Good question, though. I could honestly see, like, if you roll into Amazon for a system design interview, for like an SDE2 position or something, I could totally see a senior SDE or whatever it is trying to bust a new grad's balls by being like, so where's that account ID coming from? What service is that stored on? And it's out of scope because they just are. That would be a great way to test their ability to, I don't know, navigate ambiguity, or just it just seems like a skill that would be very, you would need that skill in the real world on the job, and testing for whether they would push back on such a requirement just seems very realistic of an expectation, in my opinion. Even though it seems like trolling or mean, but I don't know, I can see that. Okay, one is poll per 60 seconds enough. That is something you would need to clarify with your interviewer. You would definitely need to clarify that with your interviewer. So like I said, that's why I listed off like maybe once every minute, maybe once every 5 minutes. You would need to clarify with your interview. If if it's like 5 seconds or less, then you would actually not be able to do this approach of polling. You would actually need to go to the cron tab or Golang threads approach, because if the frequency, if the precision of that update in terms of seconds has more importance, where if the timing of that transaction really does have a lot of importance, and it can be a lot more precise and be at weird times, like 23 seconds past a 1 minute interval, you would need to have something more like this or Golang threads. And depending on their answer, polling might not actually be a viable option. I see that you have a select star query, which means that you're locking on to SQL DB for event timestamp. I was feeling that. Well, so we originally had it at, we originally were saying 100 TPS, which would be PostgreSQL is totally going to be able to handle that just fine on a single machine. Or DynamoDB, if we want to scale it up a lot, that would also work really well. DynamoDB does support DB triggers. And you can even do strong read consistency for the polling approach if we were going to do that with DynamoDB. So either of them actually work perfectly fine in any of the scenarios right now for the scheduling side of things, for this data store at least. So this data store, I think PostgreSQL works great for 100 TPS, and that one is for 10K plus TPS. And again, you don't want to overscale early. If your interviewer says it's only for 100 TPS, don't throw DynamoDB at it. Don't try and talk about sharding. You just need PostgreSQL. That's it, and that would work perfectly great. It would work fantastically for that scale. But if I was surprised that this was the requirement for the problem was just 100 TPS. That is a very boring scale in my opinion. It makes the problem a lot less exciting. There's a lot less challenge around such a low scale because it fits comfortably on a single machine. But if you're going to scale it up, DynamoDB, it has strong read consistency, which is actually, it's pretty solid. Strong read consistency is perfectly fine. That would work on the polling scenario. If that was important. Otherwise, it reaches consistency within a few hundred milliseconds. So eventual consistency would probably even be fine under the polling approach as well. You would maybe even want to do something mutable, where when you're doing that select, you could do a transaction where you would also update whether or not an event is processed. So optionally for the polling approach, you could maybe talk about having a status field of pending. And so then you would just have just the greater than or equal to clause. You wouldn't actually need to have that less than clause. So that's another thing that you could do is just that, and then you would and so then you would need a where clause. You would need another part of that where clause. Yeah, so that's another way to do that. Okay, I saw a couple of methods to dedupe idempotency keys versus two-phase commit. Does Kafka do native deduping? That was why I wasn't really sure if Kafka is a great approach. That's why I made sure that I also covered the that's why I said that there's the dedupe service from my original coverage of distributed cron. Currency keys. Yeah, so I really need to look that up. Two-phase commit though for deduplication. I don't think so you usually want to avoid two-phase commit. It actually is used in a couple of spots in the real world for high scale services. It has a really nasty partial failure scenario that can result in the coordinator. If the coordinator dies between the first and second phase, then it basically bricks the whole thing, which is, that's a pretty bad partial failure scenario. It doesn't satisfy the termination condition of consensus. So it's called a naive consensus algorithm, actually. But it is actually used in practice over at Dropbox. It actually does use two-phase commit in production. So I feel like they're probably doing something clever to make it more safe, but just a side note there. Yeah. So I'm just working around it I'm focusing on the idempotency keys approach. Right, we're gonna do like 2 or 3 more questions, then I'm going to move on to other approaches and trying to go through more of this problem and variation. I think this actually probably satisfies the original scope of this problem. So it solves the transaction, and then if a person is playing the game, so they have their browser, they might have some kind of backend service that they're interacting with, and they might have an account balance, might be showing up on the screen, which would just be through some other queries to the wallet service for that information. So like within the context of a bigger service, that's what would be going on, but this satisfies the original scope of the question that was answered. Just to go ahead and spell that out for you guys. I really want to cover those other variations though, by the way, because this is just like not satisfying to look at for a digital wallet. It's like you got one machine. It's very low scale. This is just very not exciting for the digital wallet part of things, but we did cover, we covered some solid approaches for the scheduling side, which is something that I don't see a lot of coverage out there in a system design interview materials for. There's not a lot of that on the scheduler side of things. All right, I'll do some questions and then we'll get into cranking up the scale in that wallet data store. How in the first design it ends up in multiple calls for the same transaction, the wallet service. You're good. It's okay. So how in the first design it ends up in multiple calls for the transaction, the wallet service? Well, so there's replicas. It's because of redundancy. It's because the cron replicas are those are redundancies. So you actually have so you have one call come into the task runner, and then you actually do multiple you do multiple writes to you got three different cron replicas there. That's just coincidentally the number of boxes on the pre-made component that I'm using. It has three things there, so that's representing like three machines in my mind. And my pre-drawn component just happens to come with three. That's why there's three arrows there. But let's go ahead and play it out. It's so we have three machines representing three replicas of the same cron tab file. So DB trigger activates. It hits our task runner, which is going to copy that data over to the cron replicas. It's going to copy it to three different machines. It's going to give three different machines the exact same copy of the cron tab file. And so all three of those machines should activate at roughly the same time. They're going to have a little bit of clock drift, but they're all going to activate at roughly the same time. And they're all going to send a call over to the SYN service or the wallet service directly. They're going to make a call. So that's how the wallet service is going to get hit three different times for the same event, is that it's just because of redundancy. Cron, what am I going to call it? The cron service has redundancy. Multiple machines will be activated for the same event UID. Yeah, good question. How many TPS can Postgres realistically scale to? That's so the number I see quoted a lot is 10,000 TPS for one machine is what I see a lot. For Redis, what I've heard once before is 100,000, but for Postgres, it's also going to depend on what you're hosting it on. So weirdly, at my current company, instead of using, so we're using AWS, at least in my department, but weirdly, instead of using built-in AWS services like RDS or like DynamoDB or OpenSearch, what we do instead is we fire up some EC2 instances. We chat with like the cloud provisioner guy, the department cloud provisioner guy. He spins up some EC2 instances for us, and then he pops PostgreSQL or Elasticsearch up on it. He might actually do something. I'm pretty sure he doesn't. Yeah, I'm pretty sure that I don't use OpenSearch or RDS. Like I interact with I can call the components directly and they're running what I'm expecting. I feel like if it was RDS or OpenSearch though, it wouldn't have the same built-in interface as the underlying software. But like that's what we do, is that we have like an EC2 instance provisioned by some guy. He fires up Postgres on it instead of just using RDS. And then depending on what your EC2 instance's size is, it's going to get some different numbers for that. And so it'll depend on what you're running it on. But like what I see quoted a whole lot, just all over the place, is 10,000 TPS. And I think I know a guy that also uses either like the Aurora AWS service, or he also has used RDS and has done some manual provisioning on it or something. And he has also told me like 10,000 TPS is like a good rule of thumb. So 10,000 TPS is the number that I have. Yeah, so like you said, it's going to depend on some other factors as well. And it's also going to depend on your the type of load that you're running against it. Is it going to be key value lookups? Or are you doing a bunch of key range queries? Because if you're doing a bunch of really big key range queries, or if your indices are set up properly, if you also need to check if you're doing proper secondary indices. And it also depends on what secondary indices. So for example, if you have a schema that's like, you got your classic lat, longe, latitude, longitude, So those can be B trees, or you can have them as an R tree. And then that's actually going to be even more performant is if you do an R tree over these two indices, you would instead actually have much faster lookup times than if you're just using two separate B trees. And it's not going to do that by default, and a lot of people don't even know that R trees are like a thing. And so like you could squeeze so much more performance in certain scenarios out, and it just depends on your workload. But like I said before, the rule of thumb that I've seen is 10,000 TPS. I feel like that's for key value lookups. I know that there's a bunch of really nice benchmarks out there too for comparing different. It's usually for like the hardware you run it on, and it's usually a little bit more oriented towards like mainframe setups or like really big beefy servers rather than I don't know, rather than what I feel would be a commodity hardware like run of the mill thing. And I think it has also been tested on some like different like open source distributed databases like Cassandra, or what is it? Cassandra was definitely one I've seen tested a lot. Elasticsearch, Redis. Look at some benchmarks. Rule of thumb I've seen though, 10,000 TPS. You can obviously squeeze more or less performance out of it though, depending on how clever you are. What DB can we use for event timestamp series? It's actually going to be a B tree. You're just going to use plain old PostgreSQL with a B tree. So there is, of course, time series databases that are out there. But the convenience of those, I feel, is more in the syntax, just like with graph databases, is that it's a little bit more of just a syntax experience, and there's not actually a lot out there for performance tuning of time series data. It's usually just a syntax benefit for the programmers themselves rather than any kind of actual algorithmic improvement for time series data itself. I want to keep going. I see there's another question that I haven't answered yet. I'm sorry. I can get it when we I can get it here in like 5 minutes or something. I want to try and make some progress on a different variation first. So I've done the scheduling part. I've done polling. What about the data store? Let's talk about how to crank up the size of the data store itself. I'm feeling like taking this polling approach because it's just easier to look at and understand than the cron replicas. So we're going to take this one, and now we're going to talk about how to how to crank up the scale on that wallet service. So we could actually have, we could even do polling at like 10,000 TPS. So let's crank it up to 100K TPS now. Let's say we're handling 100K TPS of transactions. So 100,000 calls coming into this. Let's say this can handle 1,000 TPS per machine. So we have 10 machines running this. This one, so you can either have 10 machines of PostgreSQL, or you could have DynamoDB. So like I said, it's either going to be DynamoDB or 10 machines of PostgreSQL. You're going to need to shard it at that point. You're going to need to do some sharding. And so what you could do is that you could pick, I think you're going to want to pick this one as the partitioning key. So this would be great. That would avoid having any hot partitions pretty well. You might be considering this, but maybe you would have more events scheduled for certain account IDs than others. I don't think you would have any account IDs that are getting so many transactions scheduled for it that it would cause a hot partition. But, if you're just using the UUID, that kind of guarantees an even load across the partitions. And then this would be good for a secondary index at minimum. It might be a nice sort key, but you want it as either a secondary index. I don't think you really need it as, I think You only really need to throw in a sort key if you have multiple things with the same exact partitioning key. This on its own, though, guarantees a primary key. So this is also going to be and primary key. So the primary key is a combination of a partitioning key plus a sort key. So this is going to be both of our, since we don't necessarily need a sort key here, that would mean that this is both partitioning key and the primary key. I don't know if we really need a secondary index on this, because we're not really going to be doing lookups of events by username or account ID. It's just extra data that's going to be on the UUID when we're doing our polling over a timestamp. So we don't really need anything else there. Over here, though, is where it's going to be really interesting. We're like definitely going to need to do keeping this schema. If we wanted to keep doing deduplication like this, we would definitely need to do manually sharded PostgreSQL. So manually sharded PostgreSQL, and we would have this would include the account ID in the transaction in order to properly. We're going to partition over the account ID. That's going to be our partitioning key that we're going to manually shard over, because then you wouldn't have to do a multi-partition transaction. You'd be able to handle your transactions off of a single machine, and you wouldn't require doing any distributed transactions. So that's why you would definitely want to use the account ID as the partitioning key in this case. You would maybe want to do some secondary indexes though. So these would make for some really good secondary indexes. So that one's a secondary index, and you're also going to use so you're going to do deduplication of the transaction UUID. You are going to deduplicate that, so you would also probably want to use that as a secondary index. So yeah, you're going to want to put a B tree over that attribute as well. Yeah, I think that's really all you need for that. There's multiple approaches to this though, and I want to cover other approaches as well. But this is one of the most straightforward. I feel it's, well, I mean, it's not fun to handle manually sharded PostgreSQL in production, but I mean, it is an option. You know, it's just kind of like the most straightforward way to kind of think about it. It's probably also the easiest one to debug. It involves the least complicated infrastructure, not necessarily the easiest on-call infrastructure. It's manually sharding, like I said, sucks, but it's the easiest one to reason about and think about. It's probably the least expensive in terms of the amount of machines you'd have to spin up. So at my current workplace, it'd be like, oh, less boxes. That means less complexity. But at Amazon, they're going to tell you, hey, manually sharding, that sucks. You should be using DynamoDB instead, which is, I agree with that sentiment a lot more. Let me answer some questions, and then we're going to look at some of those other approaches for trying to handle this. Okay. Unrelated to this video, how to choose which DB for which use case, and how do we set indices? So there's actually so for that part, this is probably going to blow your mind, but W3 schools, check out the page on SQL. You know, go into the SQL for Beginners thing. You've probably been to W3 schools before. It's just, you know, really basic SQL syntax. They have a page on the create index statement. This totally blew people's minds on several occasions because, like, you know, you go through, I took a class on databases in college where we went through like fully normalizing a SQL schema and putting it through, you know, we did ER diagrams. We did normalization. We did all those crazy left joins, right joins, full outer joins, stuff like that. We never once talked about indexing. We talked about primary keys. We talked about primary keys in that they have to be unique. You have a uniqueness constraint. I think we even talked about adding other constraints to database, but we never talked about adding indices to our tables. We never talked about that. And I went to college in the Midwest, and most companies that I did internships with and kind of worked at in my early career were in the Midwest. And so our databases were small. They usually ran on one machine, and our number of records was usually in the thousands, maybe tens of thousands, and we were maybe handling 10 TPS. So we didn't really need indices. But if you're working on something that has 1,000 TPS rather than 10 calls per minute, you're going to need some indices on there. But yeah, there's actually a page right there in W3 Schools for how to create an index. And it was just not covered in my college class, even though we talked about full normalization and all that. It's just mind blowing. Anyways, how to choose a DB. Geez, I don't, I've gone over this a little bit. You should join my Discord group. You should be in my Discord group. And then go to the README. And then I got a thing that talks about some of the different aspects of some of the different databases. So I've talked about some of the features of DynamoDB, of Cassandra, of Spanner. I've got Cosmos DB in there. I even talk about KDB Plus, which is the really, really fancy time series database that's over in the finance industry that is used by all the hedge funds or HFTs or whatever. I've got it all, man. I even got comparisons between Kafka and RabbitMQ and all that. Next, you're also going to see materials you want to check out DDIA, chapter 3. Chapter 3 is going to be helpful. I think that should be the one that talks about LSM trees, B trees, talks about R trees really briefly towards the end. Database internals is maybe a good book as well. I totally kind of it's I've gone over this before a little bit. I've dropped knowledge on it before. I don't know if anyone actually has a chapter in their book specifically on Cassandra versus DynamoDB or versus PostgreSQL or anything like that. So I really do kind of think that's a solid question. Maybe I should just make a video on that like I did with the consistent hashing thing. I should maybe just do a video on that. But these are good ones to start with. I don't know if any of the system design interview books that I've gone through are really that great. But those are some of the considerations I also look at. So it's you want to look at the consistency level support, read heavy versus write heavy, which would be LSM trees versus B trees. And then there's some other aspects like indexing support, R tree support, quad tree support. Geohashing is another thing that's in Redis, while quad trees are in Elasticsearch. But Elasticsearch doesn't have DB trigger support, and you shouldn't use it as a source of truth, stuff like that. I think there's this is the best material on it to start with. I think is probably DDIA though. This will be my last question before I try to cover some other material and try to cover some other approaches for this. Why do we need cron replicas? DB trigger can fire at the desired timestamp and call a service, which in turn calls send service. Can you have a DB trigger fire at a timestamp? Is that I'm not sure about that. I'm not sure about that. So Redis has the time to live thing. It's TTL, and then it would fire off at the TTL expiration. So it's with triggers activated by expiration. That's actually maybe an interesting approach. That's maybe an interesting approach. PostgreSQL doesn't have that, but Redis would be good. One of your issues would be that, like, what if the one that has whatever DB trigger that you're interested in, gets the plug pulled. So then you would need to still have some replicas. You would still need to have replicas, but this would avoid having to do roll your own cron or Golang threads. So this would still be an alternative to cron, Golang threads, polling. Would possibly be an alternative to that's a really interesting idea. That's a really interesting idea, actually. Well, so if you have PostgreSQL and then you have the DB trigger and it goes to Redis, that would solve the issue with redundancy or persistence. Like the biggest issue with Redis is that it's in memory, and so then if it just gets power cycled, you lose everything. Well, with PostgreSQL, it at least has persistence. You would still want to have some kind of redundancy, I feel. So maybe you could just do Redis with redundancy, and then that would maybe solve your issue. I still want to kind of draw this out a little bit. So you don't even need the polling, though. You don't even need the polling. Yeah, that's pretty wild. Thank you for sharing your thoughts on that. I don't know if DB triggers, like as in what's built into PostgreSQL, would do that. I don't know if PostgreSQL has something like that, but Redis does. Redis definitely has that. Redis can definitely do that. And yeah, so that's innovative. We are doing some pioneering work again. This is exciting. Yeah, so you don't need that. You don't need this thing. So you have that's what we're going to name this approach, is the Redis TTL activated DB triggers. That's actually a really interesting idea. Thanks a ton for sharing that. I really appreciate it. Look at how small that diagram is. God, that is so cool. My coworkers are deathly afraid of having a lot of boxes on the diagram. And so this is just really cool. I really, yeah. Huh. Thank you for sharing that. I really appreciate it. Okay. Some scheduler, like, I'm skipping somebody else's comments. Sorry. I just am really fascinated by this. This is crazy. Like courts can run at specified time, record at DB. I've never heard of courts. Quartz Enterprise Job Scheduler. Well, so then maybe that's, well, so I see scheduler, like job scheduler, which is then like, is it kind of like the, is it kind of a cop out? So it's like, if you're implementing a job scheduler service, if you get asked to implement a job scheduler and you use Lambda, or if you're asked to implement a orchestration service and your part of your solution involves using AWS step functions, the interviewer might not be amused. So I'm trying to figure out if this is a cop out or not. Yeah, I'm curious about how much is entailed by, is it like a one component setup? You just run it off of a single machine? So if you do run it off of a single machine, I would still be concerned about redundancy, having proper redundancy to make sure that it doesn't, it might be one of those things kind of like Jenkins. I don't know how you can set up redundancy in Jenkins. I'm not super familiar with that. So it's like one, is this a cop out? A cop out solution that would make your interviewer not impressed. And then like what all is, does it have redundancy? How does redundancy work? It's great. Thank you for bringing this up. I'm now interested in like looking into Quartz a little bit more. I've not heard of it before, but it's like whenever I see something new, it's like is this a thing that where it's like oh, my interviewer wants me to have a job runner, and so then I'm using Lambda functions in my solution, and then it's like, well, that just kind of solves it for you, or Spark, or it's like your solution is that you just name the AWS service that they're trying to tell you to implement from scratch. But again, this is great. This is a great find here. But yes, I'm gonna look into Quartz. I just was like recording that just to, because yeah. Great find again. Okay, I know I skipped over somebody else in the chat. We will get back to that in a minute. I did want to try and do another approach to the wallet data store for high volume. So this is where I'm going to kind of be doing stuff a little bit more similar to what was in my coverage from, what was it, Digital Wallet. So in Digital Wallet, I did a whole bunch of different things for the wallet data store and how to scale that up. And so this whole piece right over there is just kind of like copied from my, you can use some of the other crazier approaches that I outlined in there. But some of the other ones, I think I had a transaction data store up front. So other approaches that you have a transaction data store. And so this is if you want to avoid using manually sharded PostgreSQL, and you want to have something that's a little bit more easy to scale. So if you're trying to do like DynamoDB instead and maybe do sagas, you would maybe just have the transactions data store there. And then you would have DB triggers, and you would have the wallet data store handled in a separate way. You would have this like sharded wallet data store. And how would you handle, okay. What if it's, okay, I think I also wanted to handle transactions between a pair of people instead of just an automatic deposit from the powers that be. I think that was another part that was interesting. How do you handle making this like not have issues with distributed transactions though for digital wallet? I'm just gonna pull up my notes for this. Oh, I did something similar to the inventory problem where I stored the transaction ID within the record in a list. I had a list of transactions and then I would flatten it in step 3 or something. That was really messy. I don't like that. Did I do that in most of them? So this one I think was manually sharded as well. So I just had the transaction over there. So I'll just capture it. And then I went downstream. I sent a copy over here because the account. So this is if you have, okay, so I do need, so even if I do what I'm currently doing, even if I keep it like this, and if I was doing cross account transactions instead of just a one-way transaction, you would still need to do something a little bit fancy where you might need to have a transaction data store up at the front. So I definitely want to look at that. Did I do anything where it was not with, what I want to avoid is this. I don't like how I had the transaction ID as part of where I had to do this thing with a list transactions and then flatten them later in this problem. That sucked. I didn't like that. So did I have anything that didn't do that? Okay, so this is how I can do the cross account transactions without having this transaction data store in the front. So I can keep doing the manually sharded database like I am without having to add a crazy piece in the front. Okay. Yeah, this one looked a little weird. So I kind of like this one more. This one was built on top of 2. Yeah, so then 4B was probably also built on top of 3. What did I even change here? I don't even, okay, I can't even really tell much about what I changed there. I think I know what I'm doing though. Okay. Let's see. So what I want to do next is the variation of so this top one was the variation of cranking up the volume, and then I want to remove the assumption of unlimited Robux in this next one. So this is the original prompt. That's the original prompt. I'm going to number these. That's a little bit easier to follow. what I'm doing right now is variation 2. Or that was variation 2. Now I want to do variation 3, which is cross account transaction and removing the assumption of unlimited Robux, which means that you need to do the decrement on the sender account immediately to set it to pending, and then you don't do the deposit until later is one way to do it. Otherwise, you can just go ahead and let it potentially fail at the scheduled time. So there's like 2 different ways to do the fault tolerance, and then you would just like need to clarify what the preferred behavior is with like an interviewer. And we're remove assumption of not being able to overdraw an account. How do I word that better? Remove assumption of, also we worded as unlimited Robux. That's what was in the original prompt. The original prompt said we're going to assume that we have unlimited Robux. And I was like, well, that's that's really turning this into a low ball, a softball problem. Yeah, I was like, I don't know if you would really ask this kind of problem to a senior SD. You'd probably have cross account transactions, probably have a much higher TPS. Then it would be a lot more fun. And so I'm going to have it at that kind of scenario. Okay, so you have the event. We're going to need a sender ID. So this is the we have the recipient ID. We also need the sender ID. So recipient ID, sender ID. We're gonna say it's from SDFC, my YouTube channel name. Okay, so we're sending from SDFC to UBDSU. And we're going to need both of those 2 fields are now going to need to be stored with the event UUID. Okay, and then we're going to pull for that information. We're doing the polling approach. The Redis approach was really cool. I did like that. We're going to keep it consistent with what I did up here and do the polling approach though. So now we poll, we see this event. We're going to send it over to the wallet store. Okay, and then you can record the transaction. So there's kind of like 2 ways to do it. I guess we're going to start off with the just letting it fail, and then we're going to make another one for where we're trying to just do the withdrawal from the sender account immediately in the next diagram. But for this one, we're going to have it potentially fail, where you try and do the overdraw from the first account. You don't have enough funds, and so it says transaction failed or whatever. And then there just would have to be some kind of failure logic somewhere else where it just shows the user, hey, your automatic transaction failed. So we have this, we're going to need both of those keys again over in the transaction data store. We have both of those, and then that makes the partitioning a lot more interesting when we separate it out like this. So I had 2 ways that I could present it. It was either I could have this transaction data store at the front, and then you would just go and hit the sender account first, and then you'd use a Saga for updating the recipient account. Yeah, I guess we can go ahead and switch back to doing that instead of needing to That one was a little bit more of a simpler diagram. Just overall, it had just fewer boxes. Okay, so we're gonna have this one here. And it's going to be sharded. So it can handle 100K TPS. It's going to hit the Cinder's wallet first. It's first going to go to the Cinder's wallet. It's going to decrement it by 500. Then you would have a, so you have a write-ahead log and a DB trigger off to the broker. You would use Streamline Kafka, I think. Have a DB trigger, you copy the data to Kafka. And you're going to need some task runners to pull the event out. You're going to stick it in the other wallet. Okay, so you got the message, you pull it out, and then you're going to update the other person's wallet. Okay, how do you shard this? How are you going to look them up? How are you going to find the right one for both sides of the transaction? So for the first one, so it's sharded by the account ID, then you have transactions for both. So then the first transaction, I guess you would need to record whether it was a send or a receive event. So the first one's obviously going to be a send event. You're just sending, it's like it hits the wallet service. And the first thing it does, it creates the send transaction. So it hits the first person's wallet. It's a send event. Find it through the partitioning key, send event, you record all of that. And okay, I guess you would need a third. I guess you would need to have all three. I guess you would need to have all three because you're recording the sender and the recipient, but then it's like the one that's relevant to whatever type it is. So that account ID for the sender event, it's going to be, this whole thing's going to result in 4 records. So for the first thing, it's going to be the SDFC account, the sender. Sender gets a, it's a send type. Your account's going to go down by 500. And so it's going to be the account ID of the sender. And then the DB trigger is going to go through and it's going to make a new event of the type receive. So you're going to have in the other account, it's going to go up by 500. It's going to use the same transaction UUID. The account ID is going to be the same one as the recipient instead. It's going to be a receive record. And you are partitioning over this one. Okay. So that's how you would handle that. You also want to, so there was another approach that was for if you wanted to do the withdrawal immediately and then deposit could happen at the scheduled time. So that's another way that you can kind of do it. Let me go through some questions first, and then I can try and start drawing that one out. So I skipped this person's questions earlier, and I obviously want to go through them now. Would manually sharded Postgres involve hosting multiple master Postgres DBs which have identical schema and data routed by application, or Postgres can do this internally using its partitioning feature? I don't know if it has an internal partitioning feature. I've always thought it was so there's at least, so for MySQL, there's something called by test that you can use. But you would have multiple. My impression was this one was my impression. But there's this thing called by test. It's used by YouTube for video metadata. I thought it might also be used by Dropbox. Dropbox might also be using that. It's really useful for doing manual partitioning of a SQL database. And I think it's intended though for MySQL instead of PostgreSQL. So MySQL is usually considered a little bit older, but it's what Vitess uses to my understanding. Yeah, I'm not sure if Postgres actually has anything. So Redis does have weird clustering stuff, but it's for enterprise Redis. And so I think you have to like fork over some money to whatever company it is that maintains Redis. And it might actually not be open source stuff involved in making Redis clusters work. And so I've always been a little bit weird about the distributed Redis setups, because it's not open source and I don't know if you can actually do it. I don't think it's open source and I don't think you can do it for free. I'm curious about whether PostgreSQL might be the same way if it does have any partitioning features. Okay. I have no idea what the partitioning feature is in Postgres. Maybe I'll Google that maybe I'll Google that later. I don't know if I want to stop whatever I'm doing right now and go look that up. I think Scala is also supposed to be this easier, but not sure about other limitations. So Scala I thought Scala was a little bit more of a NoSQL database. And so the issue with that is that we're doing a multi-table setup with the one over here. So with NoSQL databases, it'd be fine for the event timestamp DB, which is only one table. The issue with the wallet data store, at least with the way that I'm doing it in the currently drawn approaches, is that it requires partitioning two different tables over the same partitioning key and then co-locating them on the same machines. So that when you're doing a transaction involving a specific account ID, it would not result in having to do the transaction across multiple machines and do a distributed transaction. The way that I'm partitioning these would avoid doing a distributed transaction. So I don't know if Scala is able to do that. I know that Cassandra and DynamoDB are not really able to. Sorry, that's really annoying. Okay, there we go. Yeah, I don't know if Scala is able to do that. My impression was that it was my impression was Scala is just a re-implementation of Cassandra in C, and Cassandra is definitely not able to do table partitioning in this way. We're able to partition them quite like I'm trying to do there. So yeah, it does have some other limitations. I'll look into whether there's something built into Postgres for this, but I haven't heard about that. I hadn't really heard of anything about that quite yet. What happens to send service or calling wallet service fails? What happens if the call from send service to the wallet service fails? Or the call from cron replicas to wallet service if you're just emitting it. Well, so it should retry. So it should retry. So What if it's just down? So what if the wallet service is just completely down? That would be an outage event, and you would need to do you need to do like backfills or something. So the scenario that you're describing is one where in order for that to happen, where the this wouldn't be something you can solve with the redundancy of the cron replicas itself. So you're saying that the request properly gets the send service, and then well, I guess what if the plug gets pulled on send service, like in the middle of receiving a request and sending and trying to forward it over to the wallet service. So it's received the request and then you pull the plug on it. So I think that like maybe the cron replicas should also be doing retries. So like that was something that was kind of ambiguous to me, is like, hey, you got these things that like wake up at scheduled times and then they like do an API call. Is it fair to do expect them to also be doing retries? So what I'm describing is here, I'll go ahead and copy paste this so that I can draw it out without making that diagram too messy. So you got a request that is going from the cron replica to the send service, and then this thing gets the plug pulled. And so then you don't get a response back for that API call. You get a 404 or something. So you would do a retry from the cron replica again over to the send service, which should have a load balancer in front of it. So there should be maybe a standby machine. So like I said, you should have n+1 many machines for send service. So even under the smallest scale, I would kind of expect send service to have at least 2 machines running for it. And so if the first one's down, you would do a retry, and then hopefully that one would be able to properly contact the wallet service. But you should ideally have retries. And then, you know, what if it's actually down? Would you do, you know, exponential back off with jittering? Exponential back off with jittering. So then it's like, yeah, I don't know how that works. That usually is for like workflows with like Herd, or that Herd's a proprietary tool from Amazon, or an orchestration tool. So I don't know how you would set up exponential back off with jittering here, because the cron replicas are like time activated. They don't like, I've always wondered how you'd actually do exponential back off with jittering, if you would just like, so you have some kind of storage involved in that, right? So it's like, how would you actually do that? You definitely would need to do, so like if this is just straight up down though, where you don't have a second machine, and so your retries are just not going to go through for like the next 5 minutes. And so then it's like the call really did fail. You really can't drive that forward through the send service because it's just straight up down. And so you'd need like a backfill if your exponential back off with jittering isn't, it's like, how would you even set that up here? I'm probably going to ask somebody about that. So like, so sometimes sometimes I do these like syncs with Steve from Life Engineered, and he fills me in on things that bug me for like months on end. This is probably one of the things I'd bring to him, because I was like, I don't actually know how you would do that. I don't know if so when I was at Amazon for like 3 years, my team owns like 6 to 8 different services. Not a single one of them actually had exponential back off with jittering implemented. And that was like a thing that some principal engineer was pushing like all throughout the company. I think that's what you would do here. I don't know how you would set it up though. The way that my team would do it though is that we would do what's called a backfill. And it was a pain in the ass. You would take all the requests that failed within a period of time, and you would rerun them, and it would take like an hour or two, and you'd have to dig through the logs in order to figure it out. But that is what we would do. Okay, negative balances will be handled by DB constraints. Yes. Well, yes, I guess. Like you don't necessarily need to set it up. You would maybe do a read before you write in a transaction. So you just have a what is it like? Transaction begin. You would do your select statement. You would select the record, check that it's greater than 0, and then you would do your update statement, and you have transaction end. Otherwise, DB constraints. Yes, I don't know if DynamoDB has actual DB constraint support or something. Some databases are schema on read rather than schema on write. And so if you can't actually build them into the schema itself like you can with PostgreSQL, this is what you would do instead. But actually, we're using PostgreSQL for these, so I guess that would maybe be a fair thing to say is could just go ahead and add DB constraints, then you don't need the transaction like this. We're doing transactions anyways, though. We are doing transactions regardless, so maybe you would just use it as part of your transaction instead of necessarily having to hard code the DB constraint. I think usually when you're working with PostgreSQL, though, having constraints like that is a little bit more fair game, though. I don't think they're really as normalized with like DynamoDB, though. So Cockroach Cockroach is like the open source version of Spanner. Yes, you're right. Scala is a little bit more of a replacement of Cassandra. I did a little bit of reading on that. It's really fascinating. It seems like all they've done is rewrite it in C instead of Java. And Discord is highly crediting, Discord's giving a ton of credit Scala as being like a huge operational improvement. It's weird. Cockroach, though. Cockroach might be, that would probably handle some auto scaling for you. I guess it would handle some auto scaling for you. So it's like I said, the open source version of Spanner. That means it doesn't have the atomic clocks that allow it to be linearizable. And so then it does have some slightly less great guarantees than what Spanner provides, from what I understand. I think it's like one step down from linearizable, but I think you would still have some really good transaction support on there. It might not be linearizability, but I think you still get what's called serializability. I don't think you can have real-time constraints then. That's what you lose. So linearizability has real-time constraints, serial consistency, sequential, that's what it was. So if you don't have linearizability for consistency, what you get is sequential consistency. I'll show you guys where I get this info from. There's this wonderful website written by, I believe his name is Kyle Kingsbury. It's this guy, just really, really smart dude. It's this page right here is what I look at. So what Spanner guarantees is this or this. Actually, I don't know what the difference is between these two, huh? So if you don't have whatever Spanner has, you might end up with this. I think you need this one for real-time constraints, though. I'm pretty sure this one guarantees real-time constraints. plus linearizability's real-time constraints. You can think of strict serializability as the total order of transactional multi-object operate. That's an isolation property plus linearizability is real-time constraints. Okay. Yeah, I don't think you get that with cockroach. You don't get real-time constraints. You can have, I think you get total ordering. You would still have total ordering in cockroach, but you don't get real-time constraints is the issue. So I don't know if that's, yeah, this is a little bit trickier. I know if you do what I'm doing here, it'd be good enough, but if you are using cockroach DB, I don't know if it would partition the same way that I am. So these might still result in a distributed transaction. And then, so it probably, I heard of the way that Spanner handles transactions, and cockroach probably does them in a similar way, is that the transaction log is on, that's what they're putting on Raft. The consensus algorithm is the transaction log. And then it's doing two-phase commit against the two tables. Okay, so it's doing two-phase commit against the two tables, but then this record and this record are not necessarily on the same machine. So then the change is not idempotent, I believe. I believe that whatever you're changing here is not necessarily idempotent. I don't know how that would work. I don't know if it's really that huge of an issue with. I'd have to look into that more, but I'm not actually sure if that would be sufficient for this problem, oddly enough. That's a really complicated issue though. Yeah. Okay, this is going to be my last question before I try and do the variation where you do the withdrawal first. So one more question, then we're going to do our last diagram for the night. Would it be good to record failure to send service or wallet service in a database and then retry later? Would it be good to record failure to send service or wallet service in a database and then retry later? Good question. Okay. So you have whatever it is that's going to send off the event at some point. You hit the send service. Let's go ahead and use your proposed idea with the event timestamp DB and the DB trigger. And so we're going to take this. We're going to copy it. We're going to pop a send service into our see, here is it? Logged failures. Okay, and we got our DB trigger, but we're going to move these out and add our send service back in. Okay, so we've got that. Also, still, what if send service is down for your DB trigger? What if your DB trigger and you have this thing down? That's the issue. So I've heard that usually DB triggers will actually have a message broker in it. It'll usually here I'll draw that here in a minute. I'll draw that in a minute. So you have this, and then you try and make a call to the wallet service. So you hit the send service tries to contact the wallet service, it fails. So then you log it over here for retrying at a later point, potentially. Yeah, well, so then it's like, what if your send service is down still? Yeah. Send service or wallet service in a, well, so you, okay, so it's like, well, you can log the failure directly in the same operation from the DB trigger. I guess one thing you could have is, so you have the status from pending to completed was a thing, is so you would say, if you have that thing where you have it activated at a certain time to live at that TTL or whatever timestamp it is it's supposed to activate at, you go ahead and do the DB trigger and it tries to do that. And then when your request is done, you can go ahead and update the status to completed. And then if it's not properly moved over to the completed status, well, it would need retries. It would need retried at some point. You can have a failed status. And so if it's just one specific request that's not able to properly hit the send service, it can switch over to the failed status. And then those can be retried in the exponential backoff or whatever. So that's another approach, is that you can just go ahead and have something built into the DB itself for trying to do those retries when a service is back up. But like I said, so this was one approach. I'm just going to draw this with a dashed line so that I can show that you can either have it there, or you can even have it here. Like I was saying though, DB triggers can actually, so what I saw at Amazon was usually you'd actually stick a broker in there. Let me draw that out. So I usually don't draw this in my own diagrams, because then they would look much more comically large than they already are. But usually with a DB trigger, you will actually have like a message broker in there, and then your DB trigger is actually just trying to get the event onto the message broker. And it's like, well, that's what message brokers are really good at, is just getting the event onto there. It's you see a lot less failures of message brokers than streams. You see a lot less failures of streams like Kafka or Kinesis than you do with a service. So it's like, okay, the event went off, it got onto the broker, the stream, and then you got your task runners that are going to drive it the rest of the way. So you don't really need the send service. So you got this thing, got your DB trigger, and then you pull message off with those task runners, and then you can convert it to a proper push over to the wallet service. And so this is what I usually see. This is what I usually saw when I was at Amazon, rather than just a straight DB trigger right over to a different service. So I saw usually something that looked a little bit more like this. And so I said DB trigger, that was usually referring to this whole part right through here. And then when that downstream service is down, when there's an outage of it, those events that didn't manage to properly hit the wallet service because it was down are just accruing over here in the Kafka stream. And so then you would just do your exponential back off with jittering using these task runners against Kafka or Kinesis. I guess this is where you would usually see the exponential back off with jittering. It's you usually see it right over here in this chunk against a message broker. that would make a lot more sense. That would make a lot of sense. That actually clears a lot of stuff up, I guess. So I think this is usually what I'd see, but and then like I said, streams can be thought of as just a pure write-ahead log. What do databases have? What can you think of databases as? You can think of them as a write-ahead log with a materialized view. That's a quote that I think Martin Kleppman had referenced in his book somewhere as like one of the chapter intros. He said databases are just write-ahead logs with a materialized view. And then that means streams are just a pure write-ahead log. So this is a little bit more simplified of a component than the database itself, I guess you could even argue. Okay, let's move on to my last diagram for the night. We wanted to have a thing that would do, it was like, how do we handle those overdraws? How do we prevent them? How do we prevent the overdraws in the account? Okay, there's the arrow. Yeah, let's go ahead and copy this whole thing. Okay, so we have, we're going to add something for a transaction kickoff. And then we would have the deposit part. So there's the withdraw part, and then there is a deposit portion on this thing. There's two portions to the transaction. We're going to get rid of the DB trigger. This part is going to get removed. There's no more DB trigger. You're splitting it into two parts. The first part goes right away. So we're going to go ahead and we're going to copy that. We're going to move it over. Instead, we're going to add the transaction, timed transaction service. Okay, so you send your request in, and then the first thing it's going to do is it's going to tell the wallet service, hey, I've got a transaction that I want to have you do. Do the, what is it? Do the send part. So it's handling the send part immediately. Oh, that's a partial failure scenario. That's a partial failure scenario. Right. So you need to make two events. So what happens if you get your response back from this and then you don't create the second one for the scheduler service? So I want to handle the send part right away. And then I want to have the receive part happen at the scheduled time. Because then if the first part, the send part, would overdraw the account, the whole thing just fails immediately. And so, yeah, you're withdrawing 500 immediately. So that way you actually there's actually something that can be sent during the receive portion. Okay, but we have two events. I guess we could have a message queue, we could have a message broker, and we just have two subscribers off of it. But then I only want, so what if the first one fails, then we would still need to have the second one also not happen. Oh, you could deduplicate it. So you could still put it on a broker. You could still put it on a broker. You have a consumer that does two steps. The first one is it tries to run it through the wallet service, and that would be idempotent. And then after that succeeds, it tries to put it onto the scheduler service or broker in front of the scheduler service. I guess you can just go ahead and remove that part. I don't even know if you would need a broker at all. You would just need to make this whole thing idempotent. The reason why, oh, it's because if you have the call, okay, it's because of retries. That's okay. Okay, so you would have the timed transaction service. Okay. And you're going to put it onto a broker right away. You're going to put it onto a stream. And then you're going to give your 200 success, I guess. Well, I would kind of want to fail the transaction immediately if there's not enough funds there. Okay, so it depends on if there's a real-time requirement. Okay, so I guess if we could go ahead and have it on the broker, and then we would have some task runners. Okay, so we put it on the broker. We have the 200 okay, even though they might have funds of 0. So I lied. I'm going to have 2 diagrams. This is the first one. I'm actually going to have 2, and this first one is not going to have the real-time requirement. The second one is going to have a really crappy shot at the real-time requirement, and we're going to wrap it up because this has been on for a while now. Okay, so we put it on there. The task runner is going to pick up the message, and then the first thing it's going to do is it's going to try to run the send part. After the send part, okay, so this is step 1. So this is idempotent. They're both going to be idempotent using the event UUID. If step 1 succeeds, you can go ahead and do step 2, which is calling the scheduler service to schedule the receive event. So that one is going to be step 2. Like that. And there you go. Yeah, okay. So that's one way to do it. What if you want to fail it right away? You don't even want to have it wait to get to the other side of the broker. What if you don't want to have it give them a delayed notification that send part failed? That means we're going to have to get rid of this and get rid of that. So we would have to immediately do the transaction. First part, we would immediately have to do the send part of the transaction. And then we would either do sagas off of the wallet data store. I think that's really where I'm leaning right now, is that we would have some kind of thing like this for making the second one happen. Because otherwise you would do a call directly to that following up from part 1, but that's a really bad partial failure scenario. I think this is probably the best way to go. It's just that then you would have it coupled in a way that I don't really like. I don't really like this arrow, but that is the most fault tolerant way that I can think of this thing occurring. Yeah, I can't think of anything better than that. I can't think of anything better than that. That's where I'm gonna have to call it for tonight. So this is the immediate failure draw, while the one before was the delayed failure or overdraw. It's acceptable. And you would just need to clarify that with your interviewer, whether doing something like this is acceptable. In the ticket master problem, it's probably a no. It's probably a no. You know, you can't just be like, all right, thumbs up, I got your order for the seat. And then 5 minutes later, you email them, just kidding. We canceled your ticket. Similarly, you know, are gonna give them like thumbs up. Okay, yep, we're gonna do this transaction. And then 5 minutes later, you're like, just kidding, I can't do it. So if that 5 minute delay in the thumbs down is not acceptable, you're gonna have to do something fancier. And this is the something fancier that I currently have thought up. I can't think of something any better than this right now. And I just don't like that coupling that we have to do right there, but it's the most fault-tolerant way that I can think of. Okay, well, I'm going to wrap it up. We've made some, we've done some great pioneering work tonight. I really appreciate the Redis TTL thing that Saurav had proposed. That was really cool. Yeah, thanks for joining me, guys. I really appreciate it. I hope you guys had fun too. Yeah, it was great. Oh, I need to share the link. Right. Copy the link. I still haven't uploaded the files from last week. I've still got them saved, obviously. But there's the ScalaDraw link in case I take a while to upload the actual files. I'll hopefully have those tomorrow. But yeah, thanks again for joining me. I appreciate it. We did some great pioneering work. Yeah, it's been wonderful. I'll publish the, well, so that's what I'm doing with the GitHub repo. That's what the GitHub repo is for. Yeah, I've already got at least 50 of my problems on there, I think. Yeah, all right. I really need to wrap it up for real this time. Thanks again, guys. I'll see you guys next week, hopefully.